Hello guys, so we are going to be talking about um, AC Unit 2 AC fundamentals. So let's start. Uh, so Unit 2 AC fundamentals topics are generation of AC signal, second alternating quantities, instantaneous RMS and average values, form factor and crest factor, analysis of AC circuits, resistive circuits, inductive circuit, capacitive circuit, series RL circuit, series RC circuit, series RLC circuit, resonant circuit, series resonant circuit, numericals on all of topics. They are going to be placed in between the slides of each of them. So after each topic is completed, there will be a few numericals. We solve them together and let's see what happens. So let's start with the first topic. I'm going to write this particular, first of all, I'll just write on a fresh page. This is page number 12. Date is does not matter. Date is nothing. Let's start with today's. Again, day also does not matter. So let's start with AC circuits. So what's the first topic? No first topic. The topic which you are currently on now, generation of alternating voltage and current. So let's see what it talks about. So technically, I just require to. Truthfully, I can just for me to draw this, I suppose, but I could just understand it and then we look at the numericals and stuff, the questions. Let's see. So a few numericals in between. So only the things are necessary for that numericals. We're gonna take that through. So I don't think so I'm gonna be writing any of these topics. I just cut this through. Only the numerical part. So we'll just understand as we go over. So firstly we have got Unit 2 AC fundamentals. Generation of alternating voltage and current. Now, alternating voltage may be generated by rotating coil in a magnetic as shown in figure A or figure B. So as you can see here in figure A, there's a inductor. There is sorry, there's not a inductor. There's a resistor. This is M. This is L. This is just showing like in the indexes or something. Does not matter. This is a resistor. There are two. Uh, we call these. This is called and it's like a rotating shaft of some kind. It's called something I don't remember. It does not matter. Then there's a what is a coil. So that actually is going to be rotated in this. Then here in this case they are rotating in an anti-clockwise direction. So alternating consider is generated by rotating coil in a magnetic such as figure B. Consider rectangular coil having n turns and rotating in a uniform magnetic field with an angular velocity of omega radians per second. In anti-clockwise direction, basically clock goes like this. So we are going like this, as shown in figure 2. Okay, so this is for this one. In time t seconds, the coil rotates through an angle of theta omega t. Okay, maximum flux, which is phi m, links the coil when its plane coincides with the x-axis. Because this is the x-axis, this is the y-axis. This the coil is technically, if you not sure able to understand it, but this coil is in the what do you say? It's towards us, or like it's from us to the other side, or from their side to us. The coil is rotating like this. This circle is not the actual coil. This is the rotation of the coil. This coil is 2D in this, but it's an actual coil with circle like it's from us towards the other side. They are going like the circle inside and outside, like it's going on, like and it's rotating here. So what is happening is because the flux is getting changed again and again. Um, So basically theta m is when the plane coincides, because the answer is cos omega t. So if omega t is 0, cos 0 basically is n phi m. So phi m is the maximum. So when theta omega t is 0, or basically the axis with it coincides with the x-axis, that would become the maximum because of this formula, and t n phi equal to n phi m cos omega t, where basically nm, if it gets cut, is phi is equal to phi m cos omega t. Phi m is the maximum. So as cos omega t changes, the phi value also changes. Now what is phi m? That is also given, I think, in the for slides. So equations of alternating voltage and current. E equal to, okay, so a lot of formula here. Formulas to think through. The equations of alternating voltage and current. According to Faraday's law of electromagnetic induction, the EMF induced in coil is given by the rate of change of flux linkage of the coil. Hence, the value of the induced EMF is E equal to minus d phi by dt n phi, which is n phi, as you know, is phi m cos omega t. Actually, n phi omega cos omega t, they are not just seen there. So, rate of change of flux, E equal to minus n phi m w minus sin omega t. Is already minuses there outside, but then we've got cos omega t differentiation with time, which is minus sine, as you know. So minus sine omega t. And omega comes outside because in differentiation, the constant value with the variable, here the variable is t. So cos omega t, mein omega is a variable before t. So what is it, the coefficient? So that's a constant coefficient, right? Omega. That comes out. So it becomes minus n phi omega minus sine omega t. Minus minus gets cut, it becomes omega and phi sine, because in minus sine omega t, in minus sine omega, like minus sine theta, it just becomes basically sine of minus theta becomes minus sine theta. It doesn't matter, minus minus gets cut, and omega and phi m sine theta comes, because theta is omega t. Then when the coil has turned 90 degrees, I when theta is 90, sine theta becomes 1. Therefore, the maximum is generated, which is EM, which is basically electromotive force, if you think in that way, EMF. And EM is equal to omega n, which is, if we actually expand this phi m, it comes up to, so omega stays like that, sine theta becomes 1. So technically n stays, omega stays, and phi m is actually Bm into A, Bm being the, what do you say, magnetic field into the area. So the Bm is the magnetic, sorry, maximum flux density, Weber per meter. So Weber is the unit of flux. So flux density is per meter square. This is per area. Into the area, which just gives you maximum flux into n into omega. So E equal to Em sine theta, which is Em sine omega t. And here omega can be written as 2 pi. So that's where the next formula is given. Um, I equal to Im sine omega t. Provided the load is resistive, omega is 2 pi f, and f is, as you know, 1 by t. So em E equal to em sine 2 pi ft, which is em sine 2 pi by t into t, where t is the time period of AC current voltage. Time period is basically for one wave to go through one point. It takes how much time? So that's the time period. And 1 by t is f, which is the frequency of that wave. The value of the voltage generated depends in each case upon the number of turns in the coil, strength of the field, and the speed at which the coil or magnetic field rotates. As you can see by this E equal to this formula, omega is the, what do you say, the kind of the radium speed, the speed over here mentioned, and angular speed. N is the number of turns. Dm is the field, basically the maximum flux density. So it basically depends on field. A is the area. And so, yeah, Now, parameters of AC signal. Uh, So the two formulas we have actually got here from our formula sheet, which is important as this one. The third one, which is E equal to Em sine theta, which is Em sine. Basically, this version of it is more important because in the formula sheet, that version is which is given. Em sine 2 pi ft. This is much more complex to remember. So I think that reason this is given. It's a very simple one. Em is given, which is this. We just remember Bm into A, omega n. Omega is the into this, and sine 2 pi by t into t. So t is the time period, and yeah. Now let's see what happens at the parameters. So same formula over here also because of parameters. There's no more formulas over here. It's a bunch of baloney. So let's see. I'm not sure that they will ask these diagrams. But yeah, I'm not going to make them because a lot of this numericals don't matter. So even if they ask, I'll just keep this on the side. So if they ask, I can just go through the notes and see and mention. And I'm doing the actual question papers. On the numerical scale, I don't think I need this. Parameters of AC signal cycle. The time taken by an alternating current to complete one set of positive and negative values is called its time period. For example, 50 Hz AC is the time period 1 by 50, as I said, because the frequency is 1 by the time period. So frequency is 50. So 1 by time period. So basically time period becomes 1 by 50, right? So because 50 is equal to 1 by t. So t equal to 1 by 50. The time period is 1 by 50. A frequency is the number of cycles per second, which is also this is a weird formula that's there for this. That's P into N upon 120, where N is the number of revolutions in RPM, which is rotations per minute, and P is the number of poles. I think basically if it's north and south or two poles, right? So 2 into number of revolutions, suppose 100, and or see here they are talking about 20 volts. So if this is a formula, this is a version of the formula. I'm not sure if that's given in the actual. Okay, it's there in the formula sheet. So I think it's important to remember. F equal to P, and F is the frequency. So frequency is equal to P, which is number of poles into N, which is number of turns. Sorry, number of revolutions per minute upon 120. So here if the poles are 20, RPM is 300. So it will generate a frequency of 50 hertz, and the time will become 1 by 50 second. And according to this, you can find out uh, I, if we know IM maximum and EM maximum. Instantaneous amplitude. This is the value of the alternative quantity at a particular instant of time is known as the instantaneous value. So yeah, instantaneous amplitude is basically del dt. What is the amplitude at dt? Then we have got peak amplitude, which is the maximum value positive or negative of an alternating quantity, which is known as amplitude. Phase, and by phase and AC current is meant the fraction of the time period of that AC current which has elapsed since the current last passed through the zero position of reference. So 16 angle simply. For example, the phase of current at t by 4, where t is the time period in terms of angle is theta is omega t, so 2 pi by t to t by 4. So 2 pi by t is the 2 pi f, as you know, theta becomes pi by 2 radians. So that's the phase angle. If we are already given that's t by 4. T by 4 because t is the time period. We note this, so this just becomes easier. So yeah. Now similar the phase angle of a rotating is shown in the figure at a theta t. So you can see from these images. First we have got figure 3 where current versus the time is given. It's a normal graph where omega t equal to t by 4 is written. So I'm assuming it's sorry omega t equal to pi by what is that? Like 1 by 4 or something? Whatever it is. It's pi by 2 actually. It's supposed to be pi by 2. So at pi by 2, 3 pi by 2, at all different angles, we have got. So it's basically 1 by 4. Okay, I got it. So basically 1/4 of the time it is going pi by 2. It's simply showing that. It's very stupid way to. Yes, there's lagging, there's bleeding. So current versus phase angle. Fine, whatever. Consider this three similar single turns placed in figure 5a. So this is figure 5a. So here, as you can see, each other by alpha and beta. In this case, the values of EMFs in the three coils are the same as one. There's one important difference. The EMFs in the three phase coils do not reach a maximum of zero value simultaneously, but one after the other. So basically, if seen that curve B and C are displaced from A by B and alpha plus beta. As you can see, this is B. It's B beta angle, what do you say, lagging from A. If you think about it, means the phase difference between A and B is beta and B and C is alpha. Between A and C, alpha will be beta. The statement, however, does not give indication to A which is answer. This deficiency is supplied by using term lag only. A leading AC quantity is one which reaches its maximum value greater than the other quantity. Example figure 5b shows that B lags behind A, B lags behind A by beta, and C lags behind A in alpha plus beta. Simply because if you think about this, this angle extends back over here, right? So because it's so in this graph, you can see A is touching zero way before B is touching 0. Because when A is touching 0, B is over here. It's in the negative. And when A is touching 0, C is much more in the negative. So when it actually touches 0, B is already beta behind. If you actually extend it behind, backward, you'll understand it that in normal system, behind, it's more behind, beta, B and C. B is the beta angle behind and C is alpha plus beta angle behind. That's the phase difference. Now E equal to Em sine omega t minus beta. Okay, and C is minus alpha plus beta. So yeah, in figure 6, you can see E is Em sine omega t, and B is leading because it goes to 0 way before 5 angle before A. So EB just becomes omega. If omega t is a reference, which is for A, then it just becomes plus 5 because it's hitting 0 before A, considering the same this. Then values of alternating voltage and current. Okay, the value of alternating voltage and current keeps on changing from instant to instant. Hence, the magnitude of alternating quantity is expressed in the following ways: peak value, average value, RMS or effective value. Now, peak value is the maximum value of the alternating quantity represented by Vm. I'll just take a break. I'll just drink water and come. Just putting this on charge now. So while I'm doing it off, we'll have it up. Let's get back into it. So we have got the peak value and the average value. Peak value is understanding just maximum value of voltage, Vm, so voltage is V. Average value is basically, it could be for current or for this. In this case, it's like this. They are just taking in some small parts and integrating it over the time. Here, this is much more straightforward. So yeah, just I want to add on. This is the mid-ordinate method. Then we have got the analytical method, a standard equation of sinusoidal AC current. This is the actual one which is acting com because the other one just doesn't make sense. So it's basically 1 by base into integration I theta d theta. So average value is area of half cycle upon base length of half cycle. So suppose this, like if there's a proper wave like that, the area of the half cycle divided with the base of the half cycle. I don't know why, just because I think it's simply because if you think about the displacement, the overall is zero, so it's just half that's the reason they've taken. So in terms of mod, technically, I average is 0 to t I d theta upon t minus 0 because here if you see it's I upon t and I being Im sine theta. So we get Im by pi comes out because Im is constant, pi is constant. So we just get sine theta d theta from 0 to pi. Sine theta integration is minus cos theta 0 to pi. And if you think about it, minus cos theta, ignore this, this is bullshit, whatever this is. Sorry for cursing, but this is not useful. So cos 0 is 1 and cos pi is minus 1. And because the minus comes outside, so just becomes minus 2 inside, minus 2 becomes 2. So 2 Im by pi. I average is 2 Im by pi. So if you actually calculate it, it basically if you divide it by pi by 2, so 2 by pi is 0.637 and same for V average, same 0.637 is the same formula, just V d theta upon pi minus 0. Then root mean square one. So this is the little more difficult one. 0.637. Okay. So let's go through this one also. So Felix will sleep early. That's difficult as well. You repeated a word, but I won't be able to solve it. So yeah, let's continue. And the thing is, I understand why the motivation goes is just because it's not that interesting. So if I was doing something that's more practical, I feel it would have been more interesting. Something like math, because math is fully engaging on the time. Mostly, because more number of problems there is theory. You have more number of problems in this theory. Um, and when it is, and also, that's one of the obviously. I feel it's like if I would read the theory, I would feel improved. So I'd rather take a question at least. Then I would, for Python and for math, what I do is I just start with the question directly without thinking on the theory and shit. And what is it? If I do not understand how to do it, then I will refer to either the solution or the theory. Theory I'll refer first because then I'll at least be able to try it without looking for the answer. And even after looking into the theory, I'm not able to do it. There might be the certain things which are required to be understood through the solution. Then that is when I see the solution. It's mostly easier for maths and Python, but and they, for which it's not actually easy. We are trying to explain it and make theoretical chapters are very easy. But the problem with these two particular chapters is that there's good amount of theory, but a lot more amount of what is it? This all theory is actually just equations and stuff which are important for the numerical part of it. Mostly the questions from Unit 1 and 2, Unit 1 being basic circuits in which we learn about mesh analysis, current analysis, mostly circuit-based diagrams, ki R1 plus R2, I1 plus I2, the Kirchhoff's law of voltage and then like V1 plus V2 equal to 0 and all of that stuff. So that basically 11th, 12th stuff. Uh, that is also similar to this because those both are much more, what can I say, that's theory, but that's more like numerical theory. So it's more like if you do the numericals, you'll understand. Also, you don't understand all of this other stuff. So that's the reason it's still boring. The good thing is Unit 3 is a lot more theory. So theory, one good thing about theory is if you really want to understand and explain it, as I explained it to you, similar to economics or other theoretical subjects I'm going to do life streams for, those are actually to understand through explaining it to you because those are like economics maybe. Economics more like philosophy, humanitarian philosophy. There's a lot of like money management and stuff, which is just basic understanding of finance and stuff. So that is much easier to explain and understand, similar to the third and fourth and fifth unit. Third unit is more numericals, but fourth and fifth unit for basic electronics, this which I'm doing, it is actually pretty, what can I say, easy. So let's go and continue with this RMS. So what is RMS supposed to be? It's an effective value of AC quantity. So effective value of AC quantity, what does that mean? Let's put on my specs back. Effective value of AC quantity, it is the criterion to measure the effectiveness of an alternating current. What does that basically mean? That the RMS value of an AC current is given by that steady DC current. It is then followed through given circuit for a time does not work the same, does work the same, produces the same heat or produced by the AC. Wait, let's understand line by line. So, see, I believe in understanding stuff rather than just doing it for theory and shit. Sorry for abusing a little in between, just sort of motion which I try to throw in. So, RMS value is also known as effective value of the AC current. What is effective value? Is basically let's think about this effective value, right? RMS is root mean square value, which is the effective value of the AC quantity. Okay, it is a criterion to measure the effectiveness of an alternating current. RMS value of an AC current is given by the steady DC current, which when following through a given circuit for a given time does the same work, produces the same heat as produced by an AC current when flowing through the same circuit for the same time. I think basically, now I got it. Root mean square value is simply that you add the square roots means square roots and square rooted basically gives you an average value of how DC basically when you square something you will get it in positive, right? So there's no negative part still attached. Like here there's no negative part as you can see. It just and if you square root it just acts as a mod value, kind of like a mod. So what they've done here is that here they've squared everything, so it basically just becomes positive. Obviously, it's very exponential. So then they wanted to and divide by n, then they square root it. So what this does is it gives you an average square root value, which is similar to a DC current, because DC current is always positive, as you know, it's just a one-way current. And this AC current down half, this part is there, that just comes up, as you see. And it's an average kind of value. So you understand that. So we have got this in this formula, and according to this formula, what they do is, so this is what is it, the mid-ordinated method. They just do this through the graph and stuff. Here is the actual part. So here we understand I is equal to 0 to t I square d theta uh, by t. T again being the base value. So the mean of the square of the instantaneous value of current over one complete cycle. So I square. First let's see I square. 0 to t I square theta. Integration 0 to t I square d theta upon t minus 0. 0 is the initial value, t is the final. This is time period. It's a time period. And upper we have got I square. T equal to 2 pi. Okay, let t equal to 2 pi. Because we are assuming that the time period or the base value is 2 pi. We're just assuming that 2 pi seconds. So I just becomes square root of 0 to 2 pi. Uh, I square, so we have just substituted t k with the 2 pi. Then I equal to I am sin theta. So I k with the we can substitute I am sin theta. So first of all, we just we can what you can do is simply uh, as you know it anything if you have studied integration 0 to 2 pi, if it is what do you say same, right, up and down it is same, right, as you know. So it can also be written as 2 times 0 to pi because you are anyway square rooting it, so it is positive. So in that sense they just cut 2 and 2 from up and down and it's become the same thing. Then what they do is, so here they have shown it like as you can see 2 2 5 it's cut. But what they've cut is okay, okay, what happened, so I am sine square theta d theta on 2 pi. 2 is multiplied, so it gets cut out. Okay, so 2 is multiplied up and down. So first they do this, and they open it and multiply 2 up and down again. Uh, the simple reason is for this formula. Sine square theta is 1 minus cos 2 theta. So 2 sine square theta just becomes 1 minus cos 2 theta. That's what they write upon 4 pi. I don't know why they did that, but it's fine. Now this becomes theta minus sine 2 theta by 2. As you know, the integration of minus cos to basically cos to theta is sin to theta upon 2 because 2 this theta ka 2 comes down and this entire thing is taken out. Now where does this 2 go? So that particular 2 is over here. So sensibly this would go. This doesn't make sense. Wait a second. Theta cos to theta 2. Oh sorry, this is shit. This is not 2. This I always get confused. So this is just I am square. Sorry. This is 2 is not this is not 2, this is square. So there's no 2 there actually. So when it this is I am square and this just becomes this 4 pi. I am square is there here. This is the remember 4 pi into 2 pi because this becomes 0 and 2 pi agar if we put here this becomes sine 4 pi and any n pi sine n pi is 0 which just becomes 2 pi over here. So square root, so 2 pi 4 pi gets cut, 2 comes down. So it becomes I m square upon 2, which is the root. So I m by root 2, which is 0.707. So 1 by root 2 is 0.707. So 0.707 into I. So IRMS is 0.707 into root 2. Similar to for V. And as you know, P, which is power, is equal to I square R. Basically, V, what is power? Power is V into I, right? So V is equal to IR, right? So I square R it becomes. I square R and I RMS over here is I. So I am by root 2 the whole square into r, which is I am square r by 2 and I am square r by 2. This is the average heating effect produced in one cycle. So basically, I'll tell you why this is there. So when current is supplied, the current is not supplied according to the maximum value, but the RMS value in your main supply in your houses and stuff. So you know the 220 volts. If you actually multiply root 2 to 200 into root 2, that is the actual amount of voltage which is maximum. but which is supplied is 200, which is IRMS, VRMS. So then form part is RMS value upon average value. IRMS is 0.707 IM upon 0.637 IM, which becomes 1.1 IM, 1.1 plus or peak or amplitude factor is peak factor, which is maximum value upon RMS value, which is IM upon IRMS. This should be root 2, which is 1.414. So form factor becomes 1.1 and peak factor becomes 1.414. This is something to remember. It is there. Yeah, given this. So then IT will be given. Okay, phasor diagrams. So this is a boring product. So that's all people. Not sure these derivations will come. Should I write down these derivations? I'm actually very confused. I think what I should do is I should just go and if these derivations come in any past question paper, then I'll attempt them. If not, then I'll just leave. I feel I should do them, but yeah, I just don't feel I have enough time to do those things eventually. Like, anyways, doing for numericals now. When I finish all of those chapters through its theory and notes and presentations, like this one, then I'll be able to successfully start with my PYQs. And when I start with my PYQs, that is when I will be uh, referring to these notes again because technically you should only start reading reference which past the questions have in them. If suppose these things are not there in them, then what I can do is, which I feel are important derivations of, yeah, most important derivations of diagrams, which I feel, right? So I feel are, I'll do those. Mostly it's based on past questions. Mostly they will have those certain derivations and certain figures. So I'll just do those. If not, then I'll do all of them in time for this. So let's do someone to play and basketball tonight. Let's practice how to do any sort of cutting on this. So just board reading this. Taking on the basketball is fine. Um, so what I'm doing now, I'll go and either I can continue this or I can hopefully it's gonna not do this sometime. Because it's been a long time ago I just studied like this. So this feels kind of flexible, but I have to anyways do this to this, do this. So it seems I should be doing this. Or should I just take a clean the football and let's play? Yes, go on. You know, football is in my hand. So I think we should continue. I think we have football studies in the machine. Continue teaching and studying. And let's talk about super. So you know, So this is kind of a tough uh, time for me, but I know I have to continue teaching and studying. So, I'm studying is ridiculous. But also, see, the problem is I can take a break and play chess for some while, but the problem is very simple, and that is, first of all, I'll have diverted attention when I come back, or even if when I go to chess, I'll have diverted attention thinking I should have studied or something. So I would not be able to do both of them in the night. And secondly, if I actually leave my PC for a while, because it's on battery saver mode, it will close eventually. So then my live stream will just, yeah, close. So let's continue. I'll do as much as possible today through the numericals and everything. Let's do as much as possible. Even I think if I'm able to do the first set or second set till first or second set of numericals, I think I'll consider myself lucky. Uh, it's a lot of stuff over here, that's a problem. But there's still a good amount of theory in between, which I feel is literally very unnecessary, but fine. So let's continue. Let's do as much as possible. And once this is done, I'll play some chess before sleeping, or just sleep and wake up and study some more the same manner. I think in the morning I'll have very less diverted focus, so I will be able to do this much easily. But one more problem is in the morning, I really don't want to speak. But I feel the only way I'm able to study well is through teaching. This is the only way I can sanely do something. And that's very sad. It's fine. So let's continue with the phasor representations. Phasor or vector representations of AC quantities. A phasor can be represented mathematically two ways, a rectangular form and a polar form. Okay, okay, so this is a little, let me just give me one moment. Okay, if I just directly jumps into AC analysis. Okay, so I'll tell you what the problem is. The thing is, still up till over here, till before the numericals, here. So these one, two things, right? These two things are segregated on two pages and not as no, it's a different kind of notes which I see over here on the PPT and which ma'am has provided us through the notes. So what I'll do is, as I'm reading through this, I'll try to explain this slides. And once this both are done, then we'll jump on to the numericals. And numericals are going to be fun. Because the solution is still given over there. But I'll be doing it without the solution before. So yeah, let's at least do this first set of numericals. Then we've got the actual interesting part, which is the or a much more easier way to or easier part, which is the AC analysis, other different resistive circuits, basically by resistive circuits, inductive circuits, then capacitive circuits, then RC circuits and RC, LC, and LR circuits, then RLC circuits. I think that's pure beauty. I think RLK numericals, then would have the RCK, CK, and finally RLC, and then there's a bit of theory in the end. I feel that is um, the series RLC resonance circuit. So that's also not theory; it's more the numericals. Last part is the actual theory. The last 1 2 pages, like few pages, which is three-phase connections, which is a bit of theory. Don't think so much numericals on anyways. There are few numericals with that. Those are the numericals. So mostly these are just numerical based questions. So let's try to do as fast as possible. The faster we do these kind of questions, um, the better we are able to form an entire understanding of the entire chapter. And finally, sorry, sorry for that. But finally, be able to finish off this chapter. Sorry for saying that, but yeah, I want to kind of finish off this chapter because this is I think one of the longest chapters in the E50. After this, the other chapters are they're much more theoretical, so it is much more faster to complete with just read theory, understand theory, write theory, whatever. Read and write. So I don't need to actually write theory just to understand it, and possibly answer those questions in the theory as we understand it. Then we can write it down. And yeah, so let's go ahead. Phasor and vector representation. So a sinusoidal AC signal is represented by EP equal to EM sin omega t. EM sin omega t we have just told. Another method to represent sine wave is a vector representation of sine. Vector representation, the alternating current or voltage, um, is represented by vector rotating counterclockwise, as you can see over here. So like this, right? Or even like clockwise you can go, but this positive is anti-clockwise, this is negative. As you can see, minus JB minus theta. Now, for example, in figure 9a, here the figure 9a is not given. OP is such a vector, it's a circle, the same thing. Here, just theta given the given omega t. Uh, the maximum, so OP is a vector which represents EM sin omega t. The maximum value of AC voltage is OP, and its angle is with the x-axis gives its phase. The projection of OP on y-axis at any instant give the instantaneous value AC value voltage never producing the AC value. So OM, which is this particular projection over here, the y-axis, or this whatever you want to say, this B is OB sine omega t, right? This is sine, this is cos, and this is sine. So E equal to OP sine omega t. OP is the hypotenuse, OM is the median one. The line OP represents an AC voltage or current to satisfy the following conditions. Its length should be equal to the peak or maximum of the sine wave. So basically, this entire C is the maximum, and this is the Y, right? The Y, and this is the X. It should be in a horizontal position at the same instant as the AC quantity is 0. So it's basically over here, 3 over 0, so C equal to so angular velocity should be such that it completes one revolution the same time it takes the arc to complete one cycle. So theta is equal to omega t, that's equal to understanding. And phasor vector diagrams. Now over here, yes. So vector I is resolved into horizontal and vertical components, A plus I vector. Um, this will come. Now let's go to the numericals. This is interesting. Should I start with the numericals or yeah? Okay. For the numericals, I'm going to keep my formula sheet with me rather than actually a theory sheet because that's what's more important. I'm going to look at the answers now. Try to understand and solve it myself. And I'll show you the answer over here. So, we're going to look at follow for now for a while. So let's solve the first set of numericals. So numericals one, alternating voltage, which is represented by Vt equal to 141.4 sine 377t, or the maximum value. So what is the maximum value? Right? I think I should eat. The thing is, I don't wanna, because I feel very sleepy. So I feel I should eat something. So what that will give me some energy, mental energy. But I'll have to keep this on so that the problem in my phone is that well charged. So I have to keep on just eat for a while. Once I'm done eating, I'll just keep on talking to keep you entertained for a while. Let's see a show. I'll see a show and describe it as I'm doing. Yeah, so then we'll solve these numericals. Once at least these set of numericals are done, then we'll go to the next part of the theory. Then we are now going to solve those numericals over the first theory. Then continue on next tomorrow. And then tomorrow we will four given this one will be done.
अभी 2 दिन का डिफरेंस खत्म हो जाएगा कल इससे परसों चीजें मिलेगा अच्छा मिलेगा कंप्यूटर पर है ना मुझे ना आता है this is your opposite of right that is not depressing okay you will chat हाँ कंप्यूटर लगा आपको you have some good things here today after me
Okay. एक काम करें मैं तो एक काम करें सिंपल ये सब कुछ नहीं चाहिए सुन ये लोग खाएगा नहीं ये तो किसको दे दे और कुछ कहाँ चावल ये दाल दे दे तो चावल हाँ वही तो ये चपाती और पानी ले ले पर ऐसे अरे पापा नहीं ले ले वो खाना दे दो उल्टा हाँ चपाती ना एक चावल के अंदर दाल ना वो दाल नींद आ रही थी अभी भी देखते रहते नींद नींद तो just freaking bored. Just so freaking boring. That's what's up. I'm watching BoJack Horseman, and BoJack Horseman, the main character, fell off a building during a movie stunt. BoJack Horseman is a series I'm seeing on Netflix. I've already seen this, I just want to see it. I'm on season 5, episode 5, at the Amelia half. हाँ कर दो और कोई आईपीएल ले लो नहीं मैं दिमाग है सही है है ही नहीं तो बंद किया है मैंने ये यूट्यूब है बंद करो ये डोर बंद करो मम्मा डोर बंद करो Now I'm watching some videos by Mohawk Mangal. Yeah. So I'm watching a video on Dhruv Rathi video. Dhruv Rathi, I don't know what he's doing now. Okay, Indian reality Indian beggar scam, beggar mafia. Yeah, only come on. Mm, deny. What? What's that? Ah, chairs and food and a bit of social media. It's the right combination to get you in the mood to study it. You really get excited or doing something ahead because you are happy. But now, eventually when I start studying, I just feel sad and sleepy again. So that's the biggest problem. But feel because of something I've eaten, at least be able to go through it till uh, 9 now, so 11:30. Sorry, 10:30 max, and then we'll close for the day and sleep. And sleep. Relationship, putting this on my phone on charge. Yeah, so let's go. Just gonna keep this late and um, when the watchman come back, and then we do. Let's come back to where is one second. I'm coming towards the table. Let's start. So, we've got maximum value. Now, this is VT. So, VM is normally, so it's simple, it's 141.4 because VT is equal to VM sine omega t. So, in this case, by what is it, comparing both these equations, I get that VM is 141 and the frequency now because omega in this case being 377, omega is 2 pi f, which is equal to 377. So f becomes 377 by 2 pi, which is 377 2 into shift by approximately 60, yeah, approximately just 60. This is 0.60.001, but that feels like 60. Therefore, time period becomes 1 by 60 seconds. And instantaneous value of voltage at 3 milliseconds is simply just V at with 3 milliseconds, right? 3 millisecond is 3 into 10 to the power minus 3 second. So this is 141.4 sine 377 into 3 into 10 to the minus 3. Let's put this in the calculator and see what's the answer. 141.4 into sine. Sometimes it's hard, sometimes it's okay. 377 into 3 into 10 to the minus 3. And let's see the answer. What the 2.79. It's 2.79 volts approximately. Let's see this. Okay, the 180 into pi also is to be done because I don't know why. I think it's basically conversion of into okay. I think that's did not think of that. But shouldn't it be um shouldn't it be fine, whatever. This doesn't make sense. That's the problem. So that's 377 in radians? Okay, so that's oh. So this one is wrong, other all are correct. 1 by 60, 60 as F and 141.4. But that is actually radians, 377. And obviously 3 into 10 to the minus 2, but also into 180 to pi should be there for degrees. Because that's how we calculate normally. And I think this was for the second equation. So let's, before we, yeah. So what I'm going to do is see the second question. Yeah, this is, wait, yeah, this is for the second question. So let me just see the second question. Uh, sorry. An alternating current takes 3.3, I think it should be ahead. Yeah. An alternating current takes 3.375 millisecond. So the time to reach 15 ampere equals 3.375 to 10 to the minus 3 seconds. For the first time after becoming instantaneous, first time, the frequency is 40 hertz. Find the, so t is basically 1 by 40 seconds. Find the maximum value of current. So Im is equal to not exactly sure what this question means. 3.375 to reach 15 amperes the first time after becoming instantaneously zero. I just don't understand this question. Why? Okay, so I think the simple understanding is I equal to Im sin omega t. Then I is given, Im is asked. So I am equal to I by sin omega t, where I is 15, sin omega is 2 pi f, 2 into pi into f, is 40. And this is I think in radians. So into 180 by pi degrees into t for 3.375 to 10 to the minus 3. I'm assuming this is supposed to be it. So pi gets cut. 2 into 40 into 180 into 3.375 upon. Okay, this is kind of crazy. But I think, let's see the other. So 15, also less than this. So 15 on sine 2 into 40 into 180 into 3.375 into 10 to the power minus 3. Okay. Yeah, and it is approximately 20. So I was correct. Let's look at the solution, you'll understand. So here I is given, IN is need to be found, and 180 into pi, I've done that this time. So yeah, so just divided and got 20. So that's W for us. I said like this, that the equation of the alternating current is given up. And this I'll be able to remember. Now let's go to the third question. Okay, this is just too freaking oh, just too freaking bored, but whatever. An alternating voltage of time 0.02 seconds and maximum value of 12 volts. I think simply because the simple fact being that I have not been able to study for at least this amount of time continuously after a very long time. That is a simple reason. So my brain is hurting. Sorry. It is sleeping for food, but there's no realistic way I'm able to do that. So why not? So let's just continue. So an alternating voltage of time period. Let's just write this down. T is equal to 0.02 seconds. So F becomes 1 by 0.02, which is 100 by 2, which is 50 hertz. And the maximum value of Vm is equal to 12 volts, which is V by sine omega t. So V equal to 12 sine omega t. Then by the equation for its instantaneous value, so this is written, calculate the instantaneous value of the voltage after 0.02 seconds. So that's also very simple. V equal to, wait, 0.02 is given. But yeah, time period of 0.02. Wait, voltage of time period. So technically, it should be if it is from the instant of zero voltage and it's becoming positive. So technically 12 volts are is for the first time if it becomes positive, fully positive. It should technically be for the bleeding one. So that's yeah, this yeah, I should see the solution on this one. This okay, current 2 pi f. Okay, fine. Wait, what? Oh, f is given, right? So f I can calculate omega and then time p. Oh, okay. So I could have calculated v at 0.02 seconds and then 4 पे तो easy है. I have to make this diagram of sort. That's what I was thinking. Like if it's the entire time goes down, that's the thing. The time period is 0.20. Oh, wait. Okay, 0.002 seconds. Yeah, I love it. So that I was actually thinking like it should be zero by now. Like, but then it is 0.002. So that's where I made a mistake. Fine. This is actually pretty simple if you think about it. So I don't put it in the formula. I'm not exactly sure if I remember the fourth one extra. So in the proper 12, 13, 14. Like proper statements as much as possible. You guys. But I think I should take a break. My head is. First thing I should keep on saying while I'm charging actually. if I keep a mobile charging, then when I want to take a break, I can take a break. I take some chess on mobile. For a long time since I've been able to actually study like this. That's the reason it's so tiring. So then eventually, as the week passes and weeks pass, I'll be getting better at this. Now I think I should yeah, take a break by putting my phone on charge and play some chess for a while. Uh, or studying chess. Or I should just put my phone on charge and then yeah. Okay, so let's put my phone on charge and play maneuver. The truth is it's very freaking boring, but let's just keep it going because you know I think I should put my phone on charge, so let's do that first. Rain has stopped working. That's one thing. Not working what I've seen so unbelievably for rain. Put this thing on charge and yeah, let's continue to push through. I think if I do one proper numerically, throughout this time I'm using a pencil and scale, everything done properly in one numerical properly. I think another conference to do further numericals and study well. The truth is, I think I should focus on 20 for that. How about it being just this one question with the formulas I have? I'll not look at the answer. You tell me, but I'll just look very hard. That's sort of problem I want to answer properly as possible. And then I'm going to uh, my problem on answer properly, what answer properly, and the other this one. Then I think we have a chance for it. But I'm not doing that. So, yeah, so uh, just give me a minute. Okay. So what I've been thinking is After this, uh, what I thought is very simple. Whatever theory I read, the things I do, I'm going to be kind of understanding it and deriving the things on my own and writing them down. So with that, what we do is things which I can do on my own, things which I will see and write and figures I will draw, will do those so that at least it kind of sticks in my memory that once I've done this, then once I do it again and I'm doing a PIP, that good amount of practice I feel. And I think one thing I've learned from this entire already is that you should always start working and studying and doing stuff from the start. That's what my goal. That from the next term onwards, the first itself, I'll be completely involved in studying everything properly, including my exams, practicing and following. Which is the first itself. So what will happen is that as time progresses, I'll have enough notes to refer so I can do many times revisions. Allow me. See, the simple thing is why I'm feeling bored to do this now is simply the process was that process which I followed was very long. I just kept everything for the last day. So what happens is this feels a lot more boring when I'm doing that. So the best way is each day do from as we come out from class, you learn something, you write it down. Write the notes in class, study the morning, and the notes with the teacher, write the analysis for those. Then you can do something extra after that for any extra time for upscaling our stuff and also exercising and other things. I think that's how it should be. It's not about now because the exams are coming, I should do it. It's that every day, even a bit and bit, if you do it. What will happen is that everything, when the exams come, test come and even later, midterms, you'll have stuff prepared to allow me to study again and again well and not being bored. Because the thing is, when you do it so slowly in the end time, it probably feels better. You probably feel stressed out during the exam time, but also you have like a lot of stuff to see. Because that's stressing that one thing, and second, it's just a lot more boring also. You consider it, even though you think it's stressful, it should not be actually boring. When you're stressed, so there's some emotion felt in that. It's not boring. But the truth is, the way I have to learn this is actually pretty boring because I've got a week still. So because I have to actually still study a little more better. But if I was studying there a little better, so what I've been doing now would not have to be the regular, just something else, something extra. Not all of bullshit. And slowly now, this is the actual this is predicting the day one. Each day is a private data set. What out? And what is it? Taking it up my hand, that's possible. Well, the next one, what's in this day? Extra stuff, extra skills you want to learn, things you want to see, code, companies you want to join, and do well in them too. That kind of an attitude should be there. And it does not work out. Actually, maybe you have that attitude for the first 2, 3 weeks or even a month or 2 months, but eventually that will die out. That's what happens. What you have to do is fix all of this, fix all of this. So this thing so natural, doing all of this. And if not doing this, it will be not hopefully weird. So your brain and your things will wanting to do this thing, wanting this thing, wanting to work out, wanting to what you should do extra things which can help you in your career, business and whatever. Your sports, your communities, your friendships, your relations. Those, okay, that should be a habit that you do. And habit is what it is. So, think that it's something on this thing. So, my all these audience, through my JEE preparation, before that, my rather than the COVID time, whatever it is. Every day, we're not focused a bit, a bit, a bit. This wouldn't have happened. This wouldn't have happened at all. And there's no regret. This thing is, I don't know it. It is not for people. You know, when I come here and say, let's say, I'm going to it is multiple times. But I understand that in itself is a mistake, right? So, one mistake, like, the people is mistake, but I don't know how to answer. One thing, one thing, one thing. So let's, with this benefit attitude, start this question. That helps me boost my morale, understanding, well-being, everything. So, let's sit down first. With normal having standing up, as that with my whole project. I've taken a quick scratch my back, like scratching sticks, right? So, with a positive attitude, I will, we say, the question is also still becoming positive. So, become positive, let's start. First, we take a, let's take a sip of water to hydrate ourselves without talking for so long. Put on my specs. I've got my theory just before the numericals beside me. So, an alternating frequency. So, what I'll do is 60 hertz, and it has a maximum of 120 amperes. Frequency, so you write down the equation for the instantaneous. Equation for its instantaneous value. So simply IP is equal to IM sine omega t. And because IM is equal to 120 amperes is given to us, and F, which is equal to 60 hertz given. Therefore, omega, which is angular speed, is equal to 2 pi f, which is 120 pi, right? Therefore, IP is equal to 120 into sine of 120 pi into t into 180 by pi degrees, if it's in degrees. Uh, so firstly, we'll find out the instantaneous current value at t equal to 1 by 360 seconds from the instant when the current is equal to positive. So I of 1 by 360 is equal to 120 into sine 120 in pi into 1 by 360 into 180 by pi degrees, right? Now this I'll put in the calculator and find out the value. So 120 into sine 120 shift pi into 1 by 360 into 180 by pi shift pi and bracket close. It's 103 point, I've got 103.9 Um, so yeah, 103.9 amperes. And the second one, the time taken to reach 96 amperes. So T of 96 amperes. So I of T is equal to 96 amperes, which is equal to 120 into sine of 120 into 180 into T. Therefore, T is just equal to 96 by 120 sine inverse upon 120 into 1. Okay, this is going to be a very small value, obviously. So, fraction sine inverse, sine inverse 96 by 120 upon 120 into 180. This is 2.456, 2.459, 2.45 into 10 to the power minus n, right? Minus 3 seconds, which is equal to 0.00245 seconds. So this is correct. Now, wait, what? Okay, this 103.9 answer. Okay, I'll open the theory for RMS, average, T's, and form concept so that I'm able to do those questions. So, yeah. Yeah, written these, I've been saw. I'm not exactly sure how. Okay, so they have solved it much better. I really don't know why I can't write it like this. But yeah, I should try writing like this. Feel so sleepy now. Feel like so bored. Let's see how long has this stream been going on for. So, category of gaming, like, really? Stop stream. Let's stop stream. Alright, so, so, let's stop streaming for a while now. I'll just continue um, on tomorrow. And I'm gonna sleep for now. So, sayonara. Sayonara. Boshi boshi. I'll keep this chair on the other side and I'll just keep the chair on the side. Whatever. I'll sleep here for a while. I'll watch it on my phone and drifting off. So, Amish, sides of you. I'll be streaming, I think, chess or some horror game. I think a horror game would be apt for tonight. So I'll be streaming a horror game. probably a game which I was supposed to be playing. So I'll play that and